The story of the HQ-2 begins long before the year 2026. It reaches back to the early Cold War era when China, still in the early stages of building its defense industry, needed a serious air defense solution. At that time, China received technical documentation related to the Soviet S-75 system, the same type used in the famous incident where a U-2 spy aircraft was shot down in 1960. Using this foundation, China developed its own surface-to-air missile known as the HQ-2. While today it is considered an older, early-generation missile system, its journey, evolution, and survival into 2026 reveal much more than simply outdated equipment. Instead, the HQ-2 represents China's decades-long transformation from an importer of missile technology into a superpower capable of designing advanced systems. The HQ-2 was China's first serious long-range SAM system. In its early decades, it was responsible for defending critical airspace over major cities, military air bases, and strategic industrial areas. It used a radar-guided command guidance system, where ground radars tracked incoming aircraft and sent guidance commands to the missile during flight. What made this missile especially important in its era was the threat of high-altitude reconnaissance aircraft and long-range bombers. The HQ-2's job was simple: deny enemy aircraft the ability to penetrate airspace without consequences. The system wasn't perfect. It required significant radar support, large launch platforms, and logistical infrastructure. Setup time took hours, and once placed in a position, relocation required time and a large crew. In its early years, it was primarily a defensive asset, something used to protect a specific site, not something that could rapidly move across the battlefield. But, in the context of the time, China had what it needed: a deterrent. The presence of the HQ-2 forced adversaries to rethink the idea of freely flying reconnaissance planes or bombers over Chinese territory. Fast forward to the 21st century, and the technology landscape is completely different. Stealth aircraft, cruise missiles, drones, and hypersonic weapons dominate conversations about modern air warfare. With new HQ-9, HQ-16, HQ-22, and the much more advanced systems emerging, the HQ-2 appears old, a relic of the Cold War standing among giants. And yet, as of 2026, the HQ-2 has not disappeared completely. Instead, China upgraded selected units and began shifting the system away from primary frontline defense and toward secondary roles. Analysts believe that some HQ-2 sites have been modernized with improved radars and electronics. Others have been converted into training and testing facilities. In certain remote regions, the HQ-2 remains deployed as a cost-effective method of defending lower-priority airspace. After all, not every target requires a state-of-the-art system. To understand why the missile survived this long, we need to look at two factors: economics and strategic layering. Modern SAM systems are expensive, not just to build, but to deploy in large numbers. Advanced missiles like HQ-9 are reserved for higher-value zones, places like the South China Sea, coastal regions near Taiwan, or critical industrial hubs. But China is huge, and airspace coverage requires layered defense. By keeping older systems like the HQ-2 active in less sensitive areas, China avoids wasting high-end systems where they are not required. Furthermore, even older SAM systems have strategic value. They force aircraft to fly higher or change their route, restricting freedom of movement. They create uncertainty, and uncertainty is a weapon. Pilots must assume that every radar signature could be connected to something dangerous. Even though the HQ-2 is not meant to engage stealth aircraft or hypersonic missiles, it still delivers a strong message: the airspace is not free. In recent years, some defense analysts have pointed out that early-generation SAM systems can still be used creatively. With minor upgrades, they can be turned into bait for suppressing enemy air defense missions, absorbing anti-radiation missile attacks and revealing where enemy aircraft are located. In other words, even if not used offensively, the system still plays a part in shaping the battle space. Training is another major role. Missile crews, radar operators, logistics teams, and technicians all need real systems to learn on before graduating to newer platforms. Retired HQ-2 units are frequently used in military academies and training exercises, teaching crews how to set up, operate, maintain, coordinate radar communications, and simulate real targeting procedures. Training on such a large, operationally complex system prepares operators for the more advanced systems they will eventually work with. The year 2026 marks a symbolic point in the life of the HQ-2. Although the missile no longer represents China's cutting edge, it has transitioned from a strategic defender into a valuable background component of the nation's air defense architecture. It still stands in silent guard over remote regions and air defense bases. It still serves as a training platform. And most importantly, the lessons learned from the HQ-2 paved the way for China's evolution from reverse engineering foreign systems to designing indigenous ones. From being based on old Soviet technology to inspiring advanced systems like the HQ-9 and HQ-22, the HQ-2's legacy is much larger than the missile itself. It represents the beginning of China's journey toward becoming a modern military power. As China now develops hypersonic missiles, stealth drone integration, and advanced radar networks, everything leads back to the foundational work established during the era of the HQ-2. History tends to remember the newest and the fastest, but sometimes progress is built on quiet foundations. The HQ-2 is one such foundation. It may no longer make headlines, but without it, there would be no story of the rapidly rising missile program we see today.